All right, so now we're ready to actually calculate some probability with something that is normally distributed. So when we're doing this, there are 4 steps that I want you guys to always follow when you're calculating these probabilities. Okay, these 4 steps are going to make up the points required for any sort of problem. So make sure that you do all 4 steps. Don't skip anything. Don't say, oh, that's stupid, I'm not going to do it. No, I'm checking stuff with these, okay? It's not just good enough that you can get the correct answer anymore. I want to make sure that I'm seeing that you did the correct process to get those answers. So to find the area or find the probability associated with something that is normally distributed, the first thing you're going to do is you're going to find the z-score. Then you're going to draw the normal curve and label approximately where that z-score is going to fall on the curve. You're going to shade the appropriate region on the curve. So are we looking for the probability less than, greater than, or in between 2 values? And then finally, you're going to use Excel to calculate the area that you have shaded. So 4-step process that we're going to do for every problem. So let's get into an example. So female heights are normally distributed with a mean of 65 inches and a standard deviation of 3.5 inches. We want to find the probability that a woman is less than 72 inches tall. So first, before I start going through my steps, I'm going to go ahead and underline the things that I found that are important. So it is important that this is normally distributed. It is important that we have a mean of 65 inches. It is important that we have a standard deviation of 3.5 inches. And then from this problem, it is important that we're looking at less than 72 inches. It is important that we are being asked to find the probability. I'm going to re-underline that. Find the probability, because later we're going to work backwards. We're going to be given a probability and asked to find the person's height. So we need to recognize, am I finding a probability or am I finding a height? And then the last important thing here is that we're looking at an individual height. We're not looking at a sample of heights. We're looking at a single height. And again, that's going to become very important later on. So that's all the important stuff. So I'm going to go ahead and start this 4-step process. So the first thing we want to do is find that z-score. So z equals x, which is our data value of 72, minus the mean of 65. Remember, we put that in parentheses, so we remember to do that first. And then divided by the standard deviation of 3.5. And I have to actually calculate this quick because I don't know what the answer is. I don't remember. It's 2. And I could have done that in my head, but I didn't. Okay, so if a woman is 72 inches tall, that means she is 2 standard deviations above the mean. Okay, now we do have the empirical rule that we could use to approximate this, but remember the empirical rule was approximations. We want to be much more precise in our answers now. So we're not going to just say, oh, well, it's 2, I can use the empirical rule. No, that's not allowed. Okay, so that's the first step. So second step, draw the normal curve and label the z-score. I'm going to switch colors. So step 2, I'm going to draw the curve. There's my beautiful curve. I'm going to put a line down the middle representing the mean. Now the mean, once we've converted this into a z-score, is going to be 0. Okay, so this is the mean of a z-score. If you have a value equal to the mean, then the z-score for that value would be 0 because it's 0 standard deviations away from the mean because it's equal to the mean. Okay, so the mean gets labeled as a 0 once we have z-scores. And then I'm going to go ahead and label the z-score on my curve. So it's a positive 2. So I know I'm going to be on the right-hand side of my mean. And then 2 is kind of far-ish, maybe not that far, but I'm not really entirely sure. It's just a guesstimate. Okay. Remember, if we had our empirical rule 1 standard deviation, we probably would have labeled like right here. And we're 2 standard deviations away from the mean. Again, it's just an eyeball. It doesn't have to be perfect because I don't even know where this really should go. but that looks about right. Okay, and then we're going to shade the appropriate region on our curve. So step 3, shade the appropriate region. So for this problem, it says less than 72 inches. So our 72 inches is now being represented by this z-score of 2. So I'm going to take my curve and I'm going to shade everything less than 2. Whee! Okay, there we go. I'm done coloring. Okay, you can use this as therapy and color while you go. Okay, and then remember on this side here, over here on this far left, this shading, this coloring will go all the way to infinity because the curve of the normal distribution will never hit 0. It'll never cross this second vertical line that we have. But we're not actually going to draw that. Okay, so we found our z-score, we drew our curve, we labeled approximately where that z-score would fall. We shaded based on the keyword in the problem. So now we're ready to go to Excel to find the probability. And in Excel, we're going to use the function norm.s.dist. And I'm actually going to switch to Excel here. Got it right there. Okay, so using Excel, if I hit equals norm, did I do that right? No, norm.s.dist, and I open my parentheses. Okay, it's going to ask me for 2 things. It's going to ask me for the z-score that I found, and it's also going to ask me if I want the probability of just that z-score or if I want the probability of everything less than that z-score. And I want the probability of everything less than the z-score, so I'm going to type true. Maybe I'm going to type true. And then I should be able to hit enter. And that is the area that I shaded. That is the probability that I'm looking for. So 0.9773. Okay, let me do that one more time. So I hit equals norm.s.dist. The first thing I told Excel was the z-score that I calculated, which was 2. And then I typed true. You will always type true here. I don't remember if I mentioned that. Okay, I'm never going to ask you what is the probability of an individual being exactly 72 inches tall. I'm always going to ask you less than, greater than, or in between. So for those, we're always going to be looking at multiple probabilities added together. So I'm always going to type in true here and hit enter. And that's how we got 0.9773. So I'm going to go back to the notes. Okay, so we did norm.s.dist. I did 2, true. And we got 0.9773. So this means that the probability of randomly selecting a woman, that is not how you spell woman. Let's try that again. A woman that is less than 72 inches is 0.9773. And that makes sense if you remember that 72 inches is 6 foot tall. Most women are going to be under 6 feet tall. So you have a very high probability of selecting a woman that's under 6 feet if you pick a random woman. If my population was WNBA players, this would look much more different because the mean would be much higher. But we're looking at all the women in I think this is the US is the data that I pulled. I don't think I did the world. I think this is US. Okay. So there is one example of how to calculate a probability if something is normally distributed. So let's look at another one. Find the probability of an individual woman being more than 60 inches tall. So again, I'm going to go through and I'm going to underline or highlight the important terms here. We're working with the same mean and standard deviation as before. So we're being asked to find a probability. We're looking at an individual and more than 60 inches tall. Those are our key words here. So we're going to start our 4-step process. So step 1 is to find the z-score for this individual woman. And we're looking at 60 inches. So I'm going to do 60 minus 65 divided by 3.5. So we get negative 5 over 3.5, which is negative 1.4286. Okay, it makes sense that my z-score is negative because my data value is less than the mean. So that means we're going to be on the left-hand side of that center line. So that makes sense, and that's okay. Z-scores are allowed to be negative. Probabilities are not. Let me say that again. Z-scores are allowed to be negative, but probabilities are not. Remember, the probabilities that we get, the answer we get in step 4, needs to be between 0 and 1. So now, the second thing we're going to do is draw our curve. Ooh, let's try that again. Draw our curve. Whee! Okay, I'm going to label the center mostly because that just gives me a good frame of reference for where to put this z-score value. So the center of my curve is 0, and we're at negative 1.4286. So we're below this value because this is 0, so everything to the right of 0 is positive, everything to the left of 0 is negative. And we're somewhere between 1 and 2 standard deviations away from the mean. So again, if I eyeball it, maybe this is 1 standard deviation away, maybe this is 2, and we're at about a little less than 1.5. That looks about right to me. Again, I'm not looking for perfection as far as where you place this. I'm more looking at, okay, did you recognize it was negative? And are you recognizing that you're kind of somewhere in the middle here? We're not right up close to 0, and we're not super far away from 0 either. Okay, so we're just kind of eyeballing it, and I'm kind of looking at the empirical rule that we saw previously as my guide for where to place this. Okay, so I have z equals negative 1.4286 labeled on my distribution. So now step 3, I'm going to go ahead and shade the appropriate region. And now in this problem, we're looking at being more than 60 inches. So that means I want this probability. I want the probability of everything off to the right from my z-score, because the z-score is representing that 60 value. So I went ahead and shaded that. And then the last step, step 4, is to use Excel. So now, one of the tricky things with Excel, back in the previous example, when we did this norm.s.dist, we put in 2, true. So we told Excel where is our z-score, or what is our z-score, and do we want the probability of just this one value, or do we want the probability of everything less than this value? Keyword, less than that z-score value. So Excel is always going to assume that you are asking for the probability of being, let me try that again. Excel is always going to assume that you want the probability of being less than the z-score you give it. So if we want to find the probability of being more than some value, we are going to have to use the complement rule. Okay, so Excel, when I go into Excel and I put in norm.s.dist and my z-score, Excel is going to give me this area, what I'm shading here in pink. But I don't want that area. I want everything else. So we use the complement rule to get everything else. So in Excel, I'm going to do 1 minus norm.s.dist. Our z-score is negative 1.4286, and we're always going to put true because we don't want the probability of just this one value. We want the cumulative probability. Okay, and I can do this all in one step in Excel, or you can do it in 2 separate steps, and I'll show you both. So going back to Excel, I'm going to come over to a different, what is it doing? There we go. Okay, I'm going to go into a different column. So if I want to do this all at once, I can hit equals 1 minus norm.s.dist. We enter our z-score, negative 1.4286, comma, true. So the norm.s.dist of negative 1.4286, comma, true is going to give me the area to the left, the area that I had previously shaded in pink. By doing 1 minus that, it takes the complement of that pink area, which is the area in orange. So I hit enter, and I get 0.9234. So this is how you can do it all in one step. If you would like to do it in 2 steps, you can do your norm.s.dist, negative 1.4286, comma, true, hit enter, and then you're going to take the complement of that. So equals 1 minus 0.07656, which is 0.92344. It's the same value. Okay, so you can do the 1 minus at the end if maybe you forgot to do the 1 minus when you first went into Excel, or you didn't immediately recognize that you were going to have to use the complement rule. That's okay. All right, so coming back to the notes, so we did this and we got 0.9234, which means the probability that we randomly select a woman and she is more than 60 inches tall is 0.9234. Again, we've got a pretty good chance of picking a woman that is more than 60 inches tall. Because again, 60 inches is 5 feet. Most women are going to be more than 5 feet tall. Okay, so there's an example of how to calculate a more than probability. So we've got one more example in here. Find the probability that an individual woman is between 62 and 67 inches tall. So again, just like I've been doing, I'm going to go ahead and underline the important things. So we're being asked to find a probability. We're looking at an individual, and now we have between 62 and 67 inches. So this one's going to be a little more complicated, but not too bad. We're still going to follow our 4-step process. So the first thing we're going to do is we're going to calculate the z-score. But now I have 2 heights that I'm looking for, so I'm going to calculate 2 different z-scores. So I'm going to call that ZA, and ZA is going to be the z-score for 62 inches. So 62 minus 65 divided by 3.5 So negative 3 divided by 3.5. Nope, if my calculator would work. Negative 0.8571 is what I got. And then I'm going to do a second one. I'm going to call that second one ZB. Okay, this is really just to keep them separate from each other, but this is going to be really helpful in the future for what we're going to be doing. The fact that I'm already thinking of the smaller z-score as ZA and the larger z-score as ZB. This is going to help us later on. So 67 minus 65 divided by 3.5 gives us 2 over 3.5, which is 0.5714. So we have two heights that we're looking at, so we have to calculate two different z-scores. And the mean and the standard deviation are still the same because we're still looking at women's heights. So now step 2 is to draw our curve and label our two values. And I have more room, so I'm going to draw this one bigger. And again, I always label 0 in the middle, roughly-ish in the middle. Let's try that again. Let's try and get that a little more middle. That's a little bit better. Okay, so there's my 0 in the middle. So now I'm going to label my two z-scores. So I have negative 0.8571. So not quite a full standard deviation. Oops. So z equals negative 0.8571, and this is ZA. And then our ZB is 0.5714. So we're on the positive side of 0, and we're even closer to 0. We're only half a standard deviation away from it. So maybe right there-ish, 0.5714. Okay, and then step 3, now we have the keyword between. So we want to find the probability of being between these two heights. So I'm going to shade everything between my ZA and my ZB. Between the two z-scores that I labeled. Okay, I'm done. So that's the area that we're looking for. So now when we go into Excel, again, Excel is going to assume that I want the area less than the z-score that I give it. So I'm going to give myself a little more room here. So if I plug in this value, Excel is going to give me everything less than it. It's going to give me all of this. Okay, everything that I just crisscrossed in red is what I'm going to get when I plug in ZB to Excel. So there's too much information there from what I want. Okay, I just want from ZB down to this ZA. But if I plug in ZA to Excel, that's going to give me, let me do a more different color. That's going to give me this area, this swirly area that I just colored in. So if I take the ZB value and I take the probability that I get from plugging in ZB and I subtract the probability I get when I plug in ZA, the ZA answer probability is getting rid of the extra information that I got when I plugged in ZB. So the result is just that middle area between the two that I originally wanted. So again, you can do this all in one step, or you can find each of these individually and do that subtraction. But this is what you're going to do when you have a question asking about between. You are going to do norm.s.dist. You're going to plug in the bigger z-score, 0.5714, comma, true. Okay, that's why I called it ZB, because it's bigger. And then you're going to subtract norm.s.dist. I ran out of room. And you're going to plug in the smaller z-score, ZA. By doing the subtraction of each of these, the answer is going to be just that area in the middle that we're looking for. So, going back to Excel now, I'm going to go into a new one. So I'm going to do equals. And again, I'm going to do this all at once. So norm.s.dist, 0.5714, comma, true, minus norm.s.dist, oops, negative 0.87, now I forgot what the numbers are, 5714, 8571. Make sure I did the first one right. 5714, 8571, comma, true. This is going to give me the area in between those two z-scores, 0.5204. If you do these one at a time, so if I do, oh my goodness, typing, norm.s.dist of the 0.5714, comma, true, that's 0.7161, and then norm.s.dist of the negative 0.8571, comma, true, is 0.1967, no, 1957. So 0.71614 minus 0.19569 is 0.52045, and that's just a rounding thing. Okay, so I do the subtraction, and that gets rid of the extra probability that I'm getting off to the left that I don't want. So 0.5204 is my answer. So there's about a 52% probability that a random woman would be between 62 and 67 inches in height. And these are the only 3 cases you have to worry about with the normal distribution. What is the probability of being less than a value? That one's the most straightforward. What is the probability of being more than some value? Use the complement rule to find that probability. And finally, what is the probability of being between 2 values? You have to take the difference between the probability of the larger z-score and the probability of the smaller z-score. And as a reminder, your answer will always be positive. This final answer here always should be positive. If you get a negative answer, you probably did your subtraction wrong. Okay, it'll also always be between 0 and 1. So if you get 1.3, check 2 things. Check and make sure you don't have your answer in scientific notation in Excel. Also check and make sure that you didn't accidentally hit plus when you did that, or something else that may have changed your answer. So this is how you calculate probability with something that is normally distributed.